Hey everyone, I'm extremely happy to be here in Women on Stage conference and welcome to my session. Today we're going to talk about Fastify and how it can rescue your server performance, your Node.js server performance. But I'll start with talking a little bit about myself. So, my name is Tamar. I'm a software manager, I'm an architect, I'm a software engineer. I really love coding. And I started to be very interested in Node about a few years ago. I founded my own startup. I wrote the entire backend in Node. And from that point, I started to get really deep into that technology and explore it. You can follow me on those links. And after introducing myself, let's get to business. So, I'm going to develop a new microservice, a new microservice. So, I'm asking myself, which Node.js framework should I choose? Okay, so if I'm going to ask the crowd, if I'm going to ask like the majority of the Node.js developers would tell me, hey, listen, use Express. It's really stable. Everybody uses it. It has tons of examples. Use this. But you know what? I would like to share an interesting fact with you. So, Express current version, the last released version, is 4.18. So, my question to you is, do you know when Express released the major version 4.0? So I assume that, if I'm asking that question, so yeah, the answer is quite long. You're probably imagining 2 years, 3 years passed since 4.0 was released. But, well, actually, the answer is going to surprise you because Express has released version 4.0 at 2014, and that is 9.5 years ago. At that period, I didn't have children. I was like children without children and happy and free. And also, a lot of things happened in the ecosystem since there. Well, we have async await, we have TypeScript, we have multiple things. We have a new framework which replaced the old framework. And you know what? I have a lot of respect for Express. This framework has very large community. Express is extremely stable. There are tons of examples online. There is huge support, but the fact that they didn't release a major version for 9.5 years is making me think, at least, that don't we want all of us to try to look for a new web framework? Something which is, I don't know, more maintained, better fit to today's standards. Don't we want to look for something like that? Don't we want to try to use something like that? So, having said that, I would like to introduce you Fastify. What is Fastify? Well, Fastify is a web framework that is actually the new kid in town. It is used to write Node.js servers and microservices. And that framework claims that, first of all, they have a really good development experience. And second, they say that they're one of the fastest web framework exist. And they're even continue and saying that they're the fastest web framework exist in Node.js compared to all other frameworks. That is a statement that I think we all need to check. So this is the focus of Fastify: the development experience, the performance, as also the flexibility. They say that they're very flexible. They can integrate with a lot of things. But you know what? When someone tells me that, hey, I am the best I am the fastest framework around. I want to check it. I need to check it. So, you know what? When starting to talk about Fastify, let's start with performance and let's see whether their claim is really correct. So, we're going to start with a benchmark. So, another fact that I want to say, Fastify published in their website benchmarks that they had created. And according to those benchmarks, they are 7 times faster than any other Node.js framework exists. Happy, Koa, of course, Express, but they're saying that they're 7 times faster. I wanted to take my own benchmark and explore it on my own. So let's start with the first benchmark. On one side we have Node.js and Express, and on the other side we have Node.js and Fastify, and both of them are going head to head. And another word that I would like to say about performance testing is that you have to compare apples to apples. You have to compare two software that are doing the same activities. So we are going to write two servers that are doing the same activities. So the first benchmark that we're going to do would be extremely simple, would be Hello World, the program that, you know, we all as developers write as our first program when usually we're starting to study a new programming language. So that's what we're going to do. To take the benchmark, I used a tool that I really love called AutoCannon. Specifically in that setup, I used 10 concurrent connections, and I have sent a lot of requests to this URL at a limited amount of time. But I also recommend all of you to check out AutoCannon, as it is a really cool tool for performance testing and benchmarking. So this is our Express server from one side. As you can see, the code is extremely simple. We're just going to do a GET request that will return Hello World. And this is a Fastify server. Here again, we're going to do the same. A GET request, very simple, that would return Hello World. So let's start with taking a detailed look at the results. So here are the results of AutoCannon. First of all, I would like to look at the latency, and here I have a note. I would like to look at the 99th percentile. Why this highest percentile and not the median or the average? What is the reason? So the reason is when you're, first of all, when you're doing performance benchmarks, it is better to look at the 99th percentile, because when you're signing a contract with a third party, with someone external, with another company, and you're saying to them, all of my requests are faster than this number, you're usually taking the 99th percentile. So here the 99th percentile is 1 millisecond. And about requests per second, we can see that we were able to serve about 20,000 requests per second, and we served 221 requests in total. And on average, we have succeeded to read about 5 megabytes. This is the data, and now let's go to Fastify data. But we can see something that also here, the results look much better than Express results. The latency, the 99th percentile is 0 millisecond. But what would probably catch your eye is that we have succeeded to serve about 48,000 requests per second on average. And in addition to that, we have read about 9.1 mega, and we have served 526K requests in total. So if we're comparing the results, put them one next to another, we're seeing in this table some data that I chose. So we can see that Fastify had performed about 2.5 times faster, or twice faster than Express. So we got like double speed, or even better than that. And I think that this is extremely impressive. but maybe this was a one-time occasion. Maybe this is not consistent. Let's do another benchmark and try to test something else and see whether Fastify is still rocking. So the other benchmark that we're going to do, again, we have Node and Express on one side, Fastify on the other side, and what we can see here is that we are going to add database. We are going to add MongoDB. So one server is going to be written with Mongoose and Express, and the other one is with Fastify and MongoDB. We're going to do a post request. We're going to insert the database, a really simple object of an animal. Again, 10 concurrent connections. This is what we're going to do. Well, let's start with the code. So this is the Express server that we're looking at. Pretty simple server and runs on port 3000. The code is also simple. One post request that would just insert data into the database. And then we have the Fastify server that also we have here a database code, runs on port 3000. And on the Fastify server, what we're going to do is insert this object into the database. Okay, so let's go into the results. In Express, we can see that the 99th percentile in the latency is 3 milliseconds. We have succeeded to serve 6,500 requests per second. And, well, we have served 70K requests in total. Now let's look at Fastify results. What we can see here, we can see that first of all the latency is shorter, is only 2 milliseconds. But let's look at the requests per second. Here we have around 8,800 requests per second, and we have succeeded on average, and we have succeeded to serve 86K requests. So what did we get? If we're looking again at the results, one next to another, so we got something which is 30% faster or even 40% faster than Express. So this is, to my opinion, very impressive. I want to say one last note for Node.js developers that are, diving into that technology. So usually Mongoose creates performance overhead. Mongoose, it's an ORM, and it's created an abstraction layer above our database. So usually it's slower. So I did one last benchmark, and I replaced Mongoose with native Mongo driver and explored the results. And those are the results. And as you can see, Express becomes a little bit faster because we removed the Mongoose and we used the native Mongo driver, but still it doesn't even get to the the speed of Fastify. Fastify still performs much better. I think here again around 30%. So yeah, I want to say that the Fastify team did a really great job regarding performance. So hooray to all the developers in the team. Everyone, you deserve a crown. Good for you. Like, great job. But I looked a little bit at the code and did profiling to try to understand what makes this framework much faster. Where is the edge? Here is what I found. First of all, they use a library called FastJSON Stringify. That library is much faster than JSON Stringify that you all know. And I want to say another thing. I have played with it a little bit and created Express servers, and instead of using like body parser and all the middlewares, I created another middleware with FastJSON Stringify, and I got a boost in the performance results. So I recommend to explore this library here and to try to embrace into your microservices. Even if you're writing with Express, take a look at that and try to integrate that in your code. And another thing that gives Fastify the edge is the architecture. Their software architecture is very light. Components are talking to each other very efficiently in all the layers. So also their architecture gives them the edge for performing that well. Okay, so we've talked about performance. We've seen that Fastify performance are really good, indeed, as they say. Now let's talk about development experience. Why we're talking about that? So to answer that question, I would like to ask you all, what are you doing with a request when a request is arriving to the server? So there's a lot of things that I can give you that I have in mind. A lot of times we're using caching, so we're going to Redis and fetching some data, and in other times we're using JWT parsing. We're doing all of that, and we're accessing database, so we're doing a lot of activities. So having said that, I would just want to say that in order to switch to another technology or to add another technology to your organization, so performance is not enough. We need to have other factors, and one of them is the ease of development. It should be a technology that it is easy to develop new features in that technology. So I would like to explore the functionality of Fastify and explore the tool that Fastify gives in order to explore the tools that Fastify gives in order to write functionality and see the ease of development that we have in this framework. Let's start with analyzing the code that we've just seen. Look at the GET request. We have a route, and we're just returning hello world here. We're not doing result point send or something like that. The syntax is very, very easy. Another thing that I would like to talk about is logging. So Fastify is using Pinot, which is a library for logging, and it is considered as a very efficient library, one of the fastest around. And also look what is the syntax for adding logs. I'm creating the Fastify instance and adding an option of logger, and that is like a really simple syntax in comparison to what we know. This is how it runs. As you can see, the log messages appear, and all looks good. Also, I would like to say about Fastify is that everything is a plugin. So if you're writing routes, they are defined as plugins. Controllers are defined as plugins. DB connectors are defined as plugins. Everything is defined as a plugin. And I would like us to look at the plugin API. In order to write a plugin, so you have to implement a function that will receive three parameters: the Fastify instance, options, and a done, a function that is called when the functionality ends. Once you receive those three, once you implement this interface, so you have a plugin. Here you can see that I access the database from the Fastify instance, on which I already registered another DB plugin, and that allows me to do the database activities, operations. So here is our post, and the done function is called after this functionality is ending. How to register a plugin? As you can see, registering a plugin is a simple activity, and from the point that I register the routes here, the routes plugin, my server is ready to serve all the routes that were defined in that plugin from that moment. Another thing that I have to say about plugins is that they enforce segregation and encapsulation in a built-in way. So the global Fastify instance giving us a global scope. But when we're defining instances below the global one, so we're creating subscope and they're encapsulated one from another. So if we're defining a functionality in one scope, it would not apply to another scope because those scopes are isolated. And that is really good because software engineering wise, it gives me the possibility to encapsulate functionality out of the box. So now I want to talk about another tool that we have in order to add functionality to Fastify, which are decorators. Look here, we have a Fastify instance and we're adding a decorator like this. So it is, again, very simple, just adding, in our case, 2 strings. And I'm using that decorator one line below for printing. But then I would like to show you what's happened in a, brother scope, let's call it, or another scope which is defined, which is isolated from the previous one. In there, if I'm going to use that decorator, I would get an error. So that's demonstrate the encapsulation of the Fastify scopes. So the last thing I would like to talk about regarding adding functionality is Fastify hooks. Let's imagine that I would like to define a functionality on every route that I write in my microservice. So how will I implement that? If I won't have Fastify, what I would usually do is writing a function and then pasting that function in every route. That is a little bit like copy pasting, and I don't really like the style of it. So I would like to show you that example. We have here add hook. That add hook will give us, the pre-handler would give us the ability to add functionality before a route happening. So when those routes are executed, we have the logic inside the pre-handler that would run before. And that is a very elegant way to implement a logic that would repeat itself in routes. And that is also bounded to the scopes. So you can add hooks which are specific to a scope. After talking about all of that, let's try to do a small quiz. Just kidding, we're not in school. But I wanted us to think about common functionalities that we all need when developing microservices, and we would all think about the best way, the best approach to implement them when we're writing in Fastify. So first of all, logging each request. Why do I need that? Well, actually, a production system has to have like in the log to write each request and the request parameters or body or everything. Why is that? Well, I have a lot of stories which are not so nice that I had to debug things in the middle of the night, and the fact that I have the request in the logs and I was able to understand which parameters were transferred, how the request looks like, helped me to solve the problem. Anyway, this is best practice in production systems to log each request. So the answer is, I think that hooks here would be like a perfect fit for this. We can add a hook, even in the global scope, that would apply to each route, and when that hook applies, it will print the request. So that tool is like perfect to implement this. Now let's talk a little bit about role-based access control. What this is. So imagine that I have an admin in my server, and this admin is permitted to perform all the operations that I have in my server. Okay, that's nice. But then imagine that I have another role of an analyst, and this analyst would be able to perform only half of the operations, not all of them. So I have to find a way to limit access to multiple operations in my service according to the role of the person who is trying to send me the request. Okay, so I think, if we're talking Fastify, that can be done with a hook on the global scope that would look at the request and see with the parameters, take out the role, and then a specific plugin to each route that would help us from the role to understand whether that operation is blocked or not. Now let's talk about input sanitizing. Why this is important? Well, you always want to do input sanitizing and validate the schema, mainly to prevent all kind of attacks, all kind of, we have DDoS attacks, we have ingestion attacks. So you really want to prevent those. And in order to prevent those, you first want to validate your schema. And second, you would want to validate that, for example, if you're supposed to receive an email, you would actually receive an email and not something else. So how to do that? First of all, it can be done with a hook or a plugin in the scope of an instance, or defining a plugin for each request. So that is one possibility. But I want to show you another possibility for input sanitizing, which is built in Fastify. Look here, this is a post request that we've done in order to insert a record to the database. And here in the options section, I can transfer a schema. And if I send a request, if I receive a request body which does not match that schema, then the request is going to fail. So this is a really nice way to do that in Fastify, and you can definitely use that. Another thing that we would like to think about is CORS. If anyone doesn't know what is a CORS validation? So usually when I have a server, I would like to limit the access to this server only to specific domains, for example. I don't want all domains to access to my server. So in order to do that, we have the CORS validation and how that would be implemented in Fastify. So in Fastify, we can implement that on a plugin on the global scope. And there is a plugin of Fastify for CORS, which is defined, and you can use it like this. Another way I can think of is using the Fastify hooks to do that, but the built-in plugin that is using the global scope is a great way to do that. So the last thing I would like to talk about is blocking the access to APIs in our API gateway. Why do we need that? Well, let's assume that we don't want to open all of our API to the outer world. We don't want them to be public. We want them to be private, at least part of them. So I want to create a situation where part of my APIs are public and part of my APIs are private. Maybe I need the private API only for like internal microservices usage. I really don't know, but I would like to keep some of them private. So the way I would do it, the way I would do it, and that is my preferred way actually, is to write two microservices, and one of them would be accessible from the Nginx or API gateway, and the other one won't be accessible. But what if we want to write one microservice and block access to a certain amount of the APIs in one microservice. So we need two different plugins, and we can register those two different plugins on the instance, and then we would have a different prefix on each plugin, and on that way we are able to solve the problem. Okay, so let's say a few words about flexibility in order to wrap up. So Fastify is supporting serverless. It can integrate with AWS Lambda and Google Cloud functions very efficiently. And it can also integrate with TypeScript and GraphQL. So it has integration with a lot of the modern standards that we have. So it is very flexible, and we're able to use it in many platforms and technologies. So I want to wrap up with a note that I would like to say to you. I recommend to try Fastify when you're starting new projects, to try to insert Fastify into your organization, to implement new microservices with Fastify. There is a fear, let's call it. Developers, managers, architects are a little bit afraid usually to use more than one technology in an organization. They're afraid of the overhead of maintaining two technologies. So I think that, if you would try to insert Fastify into your organization, it would probably be side by side with existing services that are written in Express, for example. But I don't think that you need to be afraid of using two technologies for web servers, because that layer, the web server layer, is usually an infrastructure layer, and there's not a lot of maintenance there. There would be less changes on that layer. So to my opinion, that is a layer that, this, little bit of fear to work with two technologies can be, treated better. And here this challenge is less. So yeah, Fastify is a really good choice, and I recommend you all to consider Fastify in your developments and use it and enjoy the benefits of it. That was it for me. I really hope that you've enjoyed it. You're welcome to follow me on those links, and happy conferencing, and I hope you all continue to enjoy this amazing conference.